Okay kelas, Assalamualaikum dan selamat pagi. Pagi ni kita akan continue to chapter 4.3 chemical bonding. Okay, 4.2 dan juga 4.3 Right, so mula kita tengok dahulu 4.2 molecular shape and polarity. Okay, so these are the learning outcomes for this topic. So the first one, we are going to explain the VSEPR theory. Okay, B, we are going to draw the basic molecular shapes, linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Then we are going to explain the bond polarity and dipole moment. Okay, and first we look at what is VSEPR theory. Okay, so first, the valence electron pair on a central atom occupy or arrange a position in space as far apart as possible in order to minimize electron pair repulsion. Okay, so the force of repulsion between these electron pairs will increase in the order of bonding pair to bonding pair repulsion is less than lone pair to bonding pair repulsion and less than lone pair to lone pair repulsion, meaning that the strongest repulsion is between lone pair to lone pair repulsion. Okay, alright, so let us look to the comparison of bond angle due to the different type of electron repulsion on methane, ammonia and water molecule. Okay, so why we compare between these three molecules? Because CH4, okay, CH4 methane, it contain no lone pair. Okay, all bonding pair. This semua bonding pair di sini. Tiada lone pair. Okay, 1, 2, 3 and 4. Okay, and then for ammonia we have one lone pair. Okay, yang merah ni is lone pair, and then for water kita ada dua lone pair. Jadi this one dia ada bond lone pair versus lone pair. This one lone pair and bonding pair. This one all bonding pair. Okay, alright. So kalau kita tengok the bond angle semakin banyak lone pair, bond angle dia menjadi semakin kecil. Okay, bond angle kecil ni sebab apa? Sebab dia repel, tolakan ini. Okay, the repulsion makes the bonding angle become smaller. Okay, so this one is bigger bond angle. This one is the biggest lah. Okay, because dia tiada lone pair. Alright, so kita tengok dari segi molecular shape. Okay, molecular shape is the 3D arrangement of atoms in a molecule. So it affects the physical and chemical properties, and then it is predicted by a VSEPR model. Okay, so VSEPR is stand for valence shell electron pair repulsion. Okay, so kita tengok dahulu apakah basic molecular shape. So basic molecular shape is a molecule in which central atom has no lone pair electron. Okay, kita ambil yang paling simple sekali di sini adalah AB2. So kita panggil kelas dia adalah AB2, and number of bonded atoms dia ada 2 bonded atom. Okay, the number of lone pair electron 0. So the spatial arrangement of orbital according to VSEPR is 180 degrees, and the molecular shape is linear. Okay, lurus. Jadi bond angle kalau lurus is 180 degree. Okay, the second one is AB3. AB3 is has no lone pair. Jadi kalau dia tiada lone pair, okay, dia akan menjadi 3 bonding sahaja dekat sini. Jadi kalau 3 bonding, 1, 2, 3 bonding, so bond angle dia adalah 120 degrees, and dia punya shape adalah trigonal planar. Okay. The next one is AB4. AB4 ialah 4 bonding saja. Jadi kalau keempat-empat bonding ini, okay, the bond angle dia adalah 109.5 degrees, and the molecular shape is tetrahedral. So these are the shape. Okay, the shape dia adalah tetrahedral. Okay, 1 central atom and 4 bonding. Okay, surrounding the central atom. Next one is trigonal bipyramidal di sini. Okay, adalah bagi AB5. Di AB5 meaning that dia ada 5 bonding pair with no lone pair. Okay, jadi the spatial arrangement dia mempunyai angle sebanyak 90 degree dengan 120 degree. Okay, so kat mana 120 ni? Ni dekat antara in between yang ni di sini. Okay, 120 degree. And then this one, the bond angle dia adalah 90 degree. Jadi dia punya nama adalah trigonal by pyramidal. Okay. Then the last one is AB6. Okay, AB6 bilangan bonded atoms dia mempunyai 6. Okay, and then spatial arrangement dia adalah octahedral. Okay. Okay, next is how to draw a basic molecular shape. Okay, the first step dia, okay, kita akan draw the Lewis structure. Okay, and then kita tentukan, okay, determine the number of electron pair around the central atom. Di mana kita ada multiple bonds, okay, kita kira sebagai single bond. Maksudnya kalau kita ada double bond ke triple bond, we count as one bond saja. Okay, and then find out the appropriate VSEPR theory for the specified number of electron pairs, both bonding and lone pairs. Okay, jadi kita tengok VSEPR theory. Okay, apakah dia ada mempunyai lone pair ataupun bonding pair. Okay, and then use the position of atoms to establish the resulting molecular geometry. Okay, alright. So kita tengok. Describe the molecular geometry for BeCl2. Okay, step yang pertama tadi kita perlu buat apa? Okay, draw dia punya Lewis structure. So, Lewis structure, cara nak draw the Lewis structure, kita mesti tahu number of valence electron. Beryllium 2 valence electron, 2 chlorine is 14. So total we have 16 electrons. So Be single bond. Okay, and then kita ada another 12 distribute kepada terminal atom bagi chlorine. So kita dapat, okay, Lewis structure dia BeCl2. Okay, and then kita tengok central atom kita. Jadi central atom beryllium dia ada satu central atom, dua bonding pair. Jadi kelas dia adalah AB2. Jadi find out the appropriate VSEPR geometry for the specified number of electron pairs, both bonding and lone pairs. Jadi according to VSEPR theory, repulsion between bonding pairs electron are equal. The arrangement of electron pairs dia adalah linear. Okay, alright. So use the position of atom to establish the resulting molecular theory geometry. Thus the molecular geometry is BeCl2 linear. The bond angle dia kalau linear adalah 180 degree. Okay, bond angle is 180 degrees. This is for linear shape. Okay, so number of electron pair, 2 electron pair, class dia AB2. Jadi dia cuma ada bonding pair versus bonding pair equal. Then molecular geometry dia ada linear, so the bond angle is 180 degrees. Alright, so next, describe the molecular geometry for BF3. So the first step is, we draw the Lewis structure for BF3, where it have 3 bonding pair with no lone pair. Boron has no lone pair. So 3 electron pairs all are bonding pairs. So the class is AB3. So VSEPR is bonding pair versus bonding pair electron equal, and the geometry is trigonal planar. So the molecular geometry is trigonal planar. So thus the bond angle is 120 degrees. Dekat sini 120 degrees. Okay. Why 120 degrees? Because the shape is trigonal planar. Okay, so these are another example of basic molecular shape, which is the tiada lone pair. Okay, CO2 BH3. Okay, then we have CH4 tetrahedral, BCl5 trigonal bipyramidal, SF6 is example of octahedral. Okay, so later you all boleh refer semula. Okay, this one. Alright, next kita tengok bond polarity dan juga electron negativity. In a covalent bond, electron are shared between two atoms. Okay, dalam covalent bond, electron kita share di antara dua atom yang bonding itu. Each atom has a different electron negativity based on Pauling scale. So electron negativity is the ability of an atom to attract the shared electron in a covalent bond. Dia adalah kecenderungan untuk dia tarik elektron kepada covalent bond. Jadi the bond polarity dia different is based on different in electron negativity between atoms in a bond. Jadi bond polarity is a measure of how equally or unequally the electrons in any covalent bond are shared. Jadi dia menunjukkan bagaimana cara dia berkongsi. Okay. Di bond polarity, electronegativity difference dia less than 4, dia adalah non-polar covalent. Kalau dia between 0.5 sampai 1.9, dia mempunyai polar covalent. Kalau dia greater than 2, meaning that dia mempunyai different electronegativity, totally different, so dia adalah ionic bond. Okay. So the covalent bond, polar covalent bond dengan non-polar covalent bond. Okay. So the difference there, polar covalent bond is a covalent bond formed between two different atoms and equal sharing of electron. For example, kita ada HF dan juga HCl. Yang kedua, kita tengok non-polar. Okay, non-polar kita ada polar covalent bond between two similar electron atoms, and then it has a equal sharing of electrons. The example is H2 dan juga Cl2 because dua-dua mempunyai same electronegativity. Okay, next kita tengok bond dipoles. Bond dipoles is covalent bond between the two atoms with different in electronegativity. Jadi the direction of polarity, okay, of a polar bond can be symbolized by a vector bond dipoles. The cross end of the arrow is the positive and the arrowhead is the negative end. Okay, example kita ada H dan juga Cl. Jadi kita tengok what is dipole moment. Okay, dipole moment dia simbol macam micro tu. Okay, dipole moment is a quantity measure of the polarity of a bond that can only be measured experimentally. So dipole moment is defined as the product of the magnitude of the charge and the distance that separate the center of positive and negative charge. The dipole moment is given by charge times distance. Jadi kita ada kat sini, dipole moment sama dengan charge darabkan dengan distance. Jadi charge simbol dia kita letak Q, Q darab R. So for bond dipoles versus dipole moment, this is for non-polar molecules. The overall resultant dipole moment of a molecule is the sum of its bond dipole. Okay, jadi maksudnya di sini keseluruhan untuk dipole moment dia merupakan hasil tambah untuk dipole moment, bond dipole. Dan we take the example for CO2. In CO2, the bond dipoles are equal in magnitude but exactly opposite each other. Okay, and then the overall dipole moment is 0. Okay, and the non-polar molecule has a moment is equal to 0. Bond dipole versus dipole moment for polar molecule. So the overall resultant, okay, dipole moments of a molecule is the sum of its bond dipoles. Where we take the example here is for H2O, water. Okay, water have a shape of V shape. Okay, dia mempunyai bentuk V shape, and H and O. Okay, and then H and O. So in H2O, the bond dipoles are equal in magnitude but do not exactly oppose each other. Thus, the molecule has non-zero overall dipole moment, and the polar molecule has a moment is not equal to 0. Dia maksudnya di sini dia adalah polar molecule. Okay. So what is polar molecule? So polar molecule is a molecule which has uneven distribution of electrons. Okay. Polar molecule merupakan molekul yang mempunyai penyebaran elektron yang tidak sekata. So the molecule becomes charged on each end. Okay. And one side of molecule has partial negative charge while the other end has partial positive charge. So the polar molecule has moment is not equal to 0, and we take the example here as for H2O, water. So H2O, okay, it has a slightly n pole, okay, at oxygen, and slightly positive n pole for part of hydrogen, H2O. Alright, another example is for methanol. Okay, and then this is for tetrachloromethane. Okay, methanol, the resultant dipole moment okay, is directed to oxygen, okay, because oxygen is more electronegative compared to carbon, okay, and hydrogen. And this is for CH3Cl, okay, trichloromethane. So the resultant is directed to carbon, sorry, directed to C and Cl, directed to Cl, okay, and 3Cl hydrogen is directed to carbon, okay, and then this is for ammonia. So the ammonia is resultant is directed to hydrogen, directed to nitrogen because nitrogen is more electronegative, and then 3 hydrogen directed to 1 nitrogen. Thus the resultant, okay, is upward. Resultant dipole moment. So for all these molecule, okay, it has a moment not equal to 0. The resultant dipole moment shows the uneven distribution of electron in the molecule. So for nonpolar molecule is a molecule which has an even distribution of electrons, okay, iaitu sebaran yang sekata. There is no net separation of charge and each end of the molecule has a similar charge, okay, mempunyai charge yang lebih kurang sama. And then nonpolar molecule has moment is equal to 0. The example is CCl4. So CCl4, okay, is a nonpolar molecule. Another example is CO2. This is because each bond dipoles can cancel each other and a nonpolar molecule has moment equal to 0 and each end of the molecule has similar charge. Okay, next we proceed to 4.3, orbital overlap and hybridization. So the learning outcomes, okay, at the end of this topic, students should be able to draw and describe the formation of sigma and pi bond from overlapping of orbitals, okay, and the valence bond theory. Okay, so let us discuss about valence bond theory. Valence bond theory is based on the following 4 postulate. Okay, dia mempunyai 4 postulate. First postulate is a covalent bond is formed by the overlapping of two half-filled valence orbitals of two different atoms, and the overlapping orbitals contain a pair of electrons with opposite spin. And number 3, the electron density concentrates between bonded atoms and the strength of the bond depends on the degree of overlapping. So valence bond theory describe the formation of covalent bond through the overlapping of two neighboring atomic valence orbital, and there are two types of covalent bonds based on the pattern of overlapping, which is the first one is it form a sigma bond and the second one is form pi bond. So what is sigma bond? Sigma bond is a covalent bond formed from overlapping end to end of atomic orbitals on neighboring atoms. It is the overlapping of two s orbital. Okay, it can form from two s orbitals overlap. Okay, so one s orbital and another one s orbital. So it will form a sigma bond here. Okay, sigma bond also can be formed by the overlapping of s and p orbitals. Okay, so when s and p orbital overlap, it can form a sigma bond too, and the overlapping of p and p orbital from end to end, so it can also form a sigma bond. So let us look to the example overlapping of two s orbitals in hydrogen. Hydrogen is s orbital, so the two s orbital in hydrogen will overlap and produce a sigma bond. So one hydrogen, one S, another one is one S. So the overlapping will form sigma bond. Okay, sigma bond, one S plus one S. So it forms a sigma bond, H to H bond. Another one is example for S orbital and P orbital. This is because hydrogen is from one S orbital and fluorine is from 2p orbital. So S orbital and P orbital, okay, will overlap and form S and P sigma bond. S, one S from hydrogen and 2p from fluorine. It will form sigma bond. And the next one is example of overlapping of p and p orbital. This is because chlorine is from p orbital, another chlorine from p orbital. So 3s orbital and 3p orbital. Okay, so we just take the 3p orbital from fluorine. So these two chlorine overlap and form sigma bond. Okay, 3p and 3p orbital sigma bond. So this example for sigma bond in Cl2. Okay, and then next we discuss about pi bond. Okay, the symbol is pi, 22/7. Okay, the one that you learn in mathematics. Okay, pi bond is a covalent bond formed from the side-to-side overlap of two p orbitals. Okay, dua p orbitals will overlap sideways overlapping. Okay, dari sisi ke sisi. So it will form a pi bond. Alright class, so now we take a look into the overlapping of p and p orbitals to show the example of sigma bond and pi bond. Okay, so because oxygen has one double bond, so in double bond we will have one sigma bond and another one is pi bond. So it will have one s orbital, two s orbital and two p orbital, and this is also 2s orbital and 2p orbital. So when they overlap, okay, the overlapping diagram, okay, we have px and px, okay, one oxygen, okay, py and py in another oxygen. So we will form py and py, so sigma bond, and pz and pz will form pi bond. So this is double bond, okay, sigma bond and pi bond. So this between pz and pz is pi bond. So O2, one is sigma bond and another one is pi bond. Alright, so for nitrogen N2, nitrogen will form triple bond. So N triple bond N, okay, 2s orbital and 2p orbital. So you have px, py and pz. Okay, so px, py and pz. So px and px will form sigma bond. Okay, one sigma bond. Then py and py pi bond. Pz and pz pi bond. Okay, so we have triple bond, sigma and pi, pi. So one sigma bond and two pi bond.
Alright, so that's all. Thank you, class.